storage landscape, how Flash plays a role, and what you need to know to get started. This webinar is the first in our series at virtualizationsoftware.com covering software-defined storage. After this webinar, stay tuned for 2 additional webinars in this series. The first one is Software-Defined Storage 102, where we'll cover the modern infrastructure for your Microsoft deployments, specifically focusing on software-defined storage and Hyper-V. And then after that is Software-Defined Storage 103, where we'll talk about fresh strategies for simplifying your data center, specifically how to make a smooth transition from a legacy infrastructure to a software-defined storage infrastructure, and then also how to best educate your data center teams for the future. My name is David Davis, and I'll be your moderator for today's webinar. If you do have questions during the webinar, please use the GoToWebinar question box and enter your question. We may answer the questions during the webinar, but for the most part, we'll save those questions to the Q&A session at the end. Finally, one last point I want to make is that anyone who attends this live event today and the remaining 2 events in the series will be entered to win a super cool, actually 3 super cool Pebble smartwatches, and will be awarded a software-defined storage smart certification badge from NUTANIX and virtualizationsoftware.com. So we've got a lot of exciting stuff to cover today related to software-defined storage. Just a little bit of background here before we get started on who I am and who Scott is. My name's David Davis, as I said. I started my career in enterprise IT back as a server and network admin, working in the data center, doing backups at night actually is where I started. And then I worked my way up the chain to a medium-sized enterprise where I was an IT manager, and we had a very successful server consolidation project using VMware. Recently, I've been writing, speaking, and creating video training around virtualization. I'm a VCP, a CCIE, and I've been a vExpert the last 5 years running. Today, I work at pluralsight.com, where I create virtualization video training and run my blog, virtualizationsoftware.com, along with Scott Lowe. Our first speaker and primary speaker today is Scott Lowe. Scott is the co-founder of ActualTech Media, and he's been in the IT field now for over 20 years, spending the last 10 of those years as a CIO for various organizations. He's also a micro-analyst for Wikibon and has written thousands of articles and blog posts for a variety of different websites. He's a 2-time vExpert and an MVP in Hyper-V, and he's got a unique blend of skills that are a sought-after resource for marketing collateral, white papers, ebooks, and a variety of technology firms. Recently, he's been spending a lot of time investigating, writing about, and speaking about software-defined storage. Also on the call today is our expert from NUTANIX, Dwayne Lesner, who's a technical marketing engineer and is ready to help with software-defined storage questions, especially those related to NUTANIX. So now that you know who we are, let's get this webinar started by talking about some of the ongoing challenges that we're facing in IT today. So I'd like to talk about that specifically, coming from the perspective of an IT manager in the past, where we went through the process of moving from direct attached storage to trying to justify our first storage area network, and now things are changing even more significantly. So many companies today, I would say most companies, more and more are being asked, or in many cases told, to do more with less. Align IT with the needs of the business, or simply the business isn't going to pay, the IT expenses. These aren't fancy CIO phrases. Really, these are the real world for businesses of all size. You got to do more with less and find ways to match up what you're doing in IT with the needs of the business. And who knows? In many cases, you might even find a way to help technology, make money for the company. So in IT, we have to really break down those silos. We can't have those pillars of IT infrastructure, anymore in the future. Server, network, and storage groups. Why? Well, because they're inefficient, and really we need to do more with less. We're expecting more of our, data center administrators and managers, essentially asking them to become, infrastructure engineers, really the master of the data center. So I want to challenge you all, in your IT career to become the linchpin, if you will, of the IT department, and maybe even, as I said, find a way to help technology in the data center make some profit for the company instead of forever being, the financial overhead that the company must endure. After all, they can find just about anyone to keep the lights on, in the data center. So some of you might be saying, well, that's great, but frankly, that's impossible. With our current technology in the data center, it just takes so much time to administer and even do simple things, like add capacity to the SAN. And I want to point out that I'm not saying that you're forced to do this with the technology that you have today in your data center. Specifically when it comes to storage, we'll be talking about in this webinar how the latest in software-defined storage can make the life of data center admins, so much easier, make your daily tasks, so much more efficient, and give the company, much greater agility. And finally, maybe even impress, the business leaders and executives of the company with what IT can do with technology and with the data center. After all, storage is a really big part of the data center today, and especially, even more so with virtualization. And that's because in most cases, traditional storage just can't keep up with the demands of today's modern virtual infrastructure. So with that, why don't I hand this over to Scott? And Scott, maybe you can get started by talking about how storage has evolved. Where have we come from and where are we going?
Thank you, David, for the introduction, and thank you all for being here today. We're very happy to be here today, and thank you to NUTANIX for participating in this web series and sponsoring this web series. We think it's going to be a pretty valuable web series for an emergent space, which is software-defined storage. And if you want to learn a lot about software-defined storage, I actually did write a For Dummies book on the subject that you can download for free at NUTANIX.com. Let's talk a little bit about where we started in storage. And as David mentioned, we've gone through a number of paradigm shifts when it comes to storage. And many of you may remember that way back in the day, we had these data islands that we called direct attached storage. Actually, we called them servers at the time. But we had local storage in those servers, and all of that storage was really consumed by that server and the applications that ran on that server. As you can see in the diagram on your screen, we really had a siloed stack sort of from a server standpoint. We had the applications running on an OS, which was installed on a single server, which was attached to a SCSI controller, to which we attached a bunch of hard drives. Now, we may have also attached some external arrays and things like that for particularly capacity-intensive needs. But at the time, we really created each individual application on its own island. So we really had all these resources dedicated to an application basis. Now, this was good in some ways, but not so good in some other ways. This was really easy to configure specific storage configurations to meet unique application needs. I mean, I remember back in the day when we were talking about creating a new Exchange server, creating a new database server, we had specific storage requirements, not necessarily requirements, but best practices that we would follow from a disk configuration standpoint. We didn't go into a SAN and deploy a volume. We actually went and bought a server specifically dedicated to that database application. That made it somewhat easy to procure. I mean, we had to basically build the whole thing, but we built a server for an application and deployed it in the data center. And from a latency perspective, now these were not necessarily your modern flash disks, but it wasn't terrible because we had storage proximity in the server. So we didn't have the complexity of the storage fabric to deal with when we were talking about trying to make sure that we were meeting the needs of our application. But we also had some major challenges when it came to this direct attached storage. Primarily, we had the issue of scale. Now, you're not going to be able to take that model and scale it in an affordable way. Now, we also had lots of autonomous islands of storage. So if an administrator needed to manage storage in any way, they had to go to an individual server to do so. There was not an easy, necessarily centralized mechanism to harness all of this storage. And that created a paradigm of waste, as each server island was generally over-provisioned. I used to do this, and everybody that I know used to do this. When we bought a server, it was for life. So we would go out and buy a server and say, hey, we need to make sure that this server can meet our needs for the next 5 years, or whatever, how many ever years we had in our replacement cycle. So we made sure we bought plenty of RAM, enough processor, and enough disk to last 5 years, thinking at the time that we would probably grow into that. Well, in a lot of ways, we never did grow into that. So we ended up with lots of waste in the data center in the form of this, what I would call stranded storage, that we really couldn't leverage easily without affecting that application which we carefully designed around that storage infrastructure.
Yeah, when it comes to aligning IT with the needs of the business and specific applications, this actually made sense. I mean, you were purchasing server and storage specifically for a particular application, and in most cases that application was tied back to an IT department, for example, payroll or HR. And it worked well, for a while. You could easily, justify out those costs, and you could easily, spec out the needs of that particular application. But as Scott said, over time, the CPU, the compute, and the storage just was becoming wasted and was sitting idle.
So what did we decide to do to try to combat some of this stuff? Really the storage area network was sort of the original virtualization, if you really think about it. When we started our virtualization projects, we really attacked them by taking some of that low-hanging fruit that we had, print servers and other important but not mission-critical systems, and combining them into the virtualization basket in order to achieve some economies of scale and to just save some money. So we would take these servers that were maybe hitting end of life or that were unreliable or for whatever reason we needed to eliminate from the data center, and we started putting them on virtual hardware. Well, with the storage area network, we didn't necessarily virtualize it. What we did is we still combined those workloads into what you see on your screen, which is the storage area network. Now, even without the hypervisor layer there, we were using these SANs in order to share storage resources across all of our servers. Now, bear in mind, storage has often been one of the most expensive resources that we have in our data center. So even before the rise of the hypervisor, we wanted to find ways to basically maximize or optimize our use of the scarce resource, really, which is storage. So we created the storage area network with fiber channel and later iSCSI connectivity, and we created basically an entirely separate storage network that all of our servers could leverage and then share that critical storage resource in ways that made more economic sense. Now, on the plus side of this, it does enable more efficient use of storage. It really does, because even if you over-provision this, you're over-provisioning once. You're not necessarily over-provisioning across each individual server. And also, many storage area networks eventually came to have features such as thin provisioning and some other services which enabled us to over-provision at will and sort of achieve storage capacity gains even in spite of ourselves. Some people consider thin provisioning cheating a little bit, but thin provisioning is a way that we can continue to kind of think about servers the way we always have, which is let's provision what we know we're going to need for the next few years without actually wasting that capacity until it's necessary. Now, this also provided us with a much easier resource pool to manage. We now had a single central storage resource to administer rather than potentially hundreds of resource islands that we had to deal with. But there were some significant downsides to the SAN. Now, these may not have been apparent at the beginning of the life of the SAN, but over the years, many of these have risen their ugly heads and become major issues. First of all, they're kind of expensive. I mean, if you go to an EMC or NetApp or, really if you look at some of the tier 1 players, a SAN is not a small investment, especially for a smaller organization. It can be a really tough thing to swallow when you have to go out and spend tens of thousands of dollars or hundreds of thousands of dollars on a SAN just to get some of the economic benefits that we talked about before, which is more efficient use of resources and such. As we started looking at virtualized workloads, we also started looking at more of what we call the I/O blender. So rather than have nice, neat storage that's specifically designed for an application, we basically threw all kinds of applications into the pot and fold the SAN to figure it out. Here's an example. If you think about writing and streaming media to a hard disk, that's a pretty good use case for a hard disk because hard disks like sequential writes. So when you're laying down a movie or something to a disk, you can just have the hard disk write head sit on the disk and write until it's happy. because all of that information is going to be sequential. But when we start looking at random workloads, such as you get with databases and such, and even just file access, hard disks start to suffer because every time you have to pick up that read head and move it around the disk, you add latency and you reduce your overall ability to push I/O through that disk. So as we started to see SANs built on lots and lots of hard disks, we ended up with issues where workloads were outstripping the performance capabilities of the SAN itself, and we ended up in situations where we would simply just throw more hardware at the SAN. So you know, I don't know how many of you heard the phrase, "Let's throw some spindles at it" in order to solve a performance issue. We didn't need the capacity, but we needed the IOPS. So we'd simply buy more disks or resort to capacity limiting ways to achieve better performance, such as short stroking, which only allows you to use a fraction of the capacity of the disk. So we were really going to some great lengths to get the best possible storage out of these SANs and hope that we didn't have a lot of network-induced latency issues as we moved ahead with the SAN in our environments.
Scott, let me ask you a quick question here from the perspective of, you know, the average server or storage admin out there. I mean, you know, they might be asking the question, wait, you know, back in, say, the late 90s, we were all told that SAN was the future of storage in the data center, and that, you know, we need to move from direct attached storage to SAN, and you know, we were convinced that that was the best place, you know, to store our data, you know, now and forevermore. So what happened?
Well, you know, to counter that, I would say back in the 90s, I was told that Novell was the future of computing. Basically, things change. You know, as we, even, you know, when I first started my IT career, I was knee-deep in NetWare. And today, it's gone. It's one of those things where it was going to be huge. And SANs, obviously, are still one of the most common ways by which storage is procured and deployed today. There's still a lot of use cases around SANs, but I think what we're seeing is it's just some of the emerging workloads. For example, VDI, big data. There's a desire to do things a bit differently. We're also hitting an era where IT has to be more scalable than they were in the past, and a lot of people like to call this web scale IT. And now that doesn't mean we have to be a Facebook or a Google, but we need to act like it to a certain extent. We have to have the ability to more easily push our infrastructures to support the new needs of the business that we're not even anticipating yet. So we have to be prepared to be able to support what we're not even 100% sure we're going to need to support down the line in a way that makes economic and technical sense. And that can be kind of tough to do with a SAN because it's sort of a fixed array of hardware and software. And yes, it's expandable, but there's a lot of decision points to have to go into how you expand and the capabilities of expanding those units. Now I want to touch briefly on network attached storage as well. This is basically, as you know, another type of storage that we've seen in the network. It has similar pros and cons to a storage area network, but I believe we have some additional potential for even more latency than we would normally see in the storage I/O equation, because of the fact that there's so many NAS devices out there that are in departmental situations where they may not have a dedicated storage infrastructure to support their needs. So they may be sharing that Ethernet link with other applications, which could add potential latency to the I/O equation. David, do you have any thoughts there?
Yeah, I mean, I just want to say, I think that this is probably the model that most or the majority of, you know, virtual infrastructures are using today for storage. You know, either iSCSI or NFS to an array, you know, where they store their virtual machines. And, you know, for the most part, it's working. The Ethernet network has relatively low latency. You know, maybe they have certainly a dedicated network. They might be moving to 10 gig Ethernet. So to me, this is the software-defined storage models, you know, that are evolving right now. This is kind of what they have to compete with, along with, you know, enterprises that are using large SANs. Would you say
oh, sorry, David.
Would you say that's the case, Scott?
Yeah, I would agree with that. One of the things I should point out for everybody watching is obviously not all network attached storage devices are sharing the front-end Ethernet with everybody else. There's lots of NASs that do have their own storage infrastructure, but and they look more like SAN environments. And that's when you're using things like NFS or SMB for handling virtual machine traffic. But this is just another physical architectural method that I've seen out in the real world that people are contending with as far as struggling with overall performance in the virtualization landscape. So we have these storage performance issues sort of raising their heads. And when we really think about the early 2000s to mid 2000s, storage was a pretty boring place. I mean, way back in the early 2000s, we got the really exciting advancement of 15K RPM disks that spun faster than their older cousins. And that was about as exciting as it got. Now, from a performance standpoint, that was good, but it wasn't necessarily revolutionary. It was much more of an evolutionary mindset change than a revolutionary one. But we've had Flash around for quite a while, but it's only the last few years that Flash has really become what we would consider an accessible storage device for the mainstream. And I do see Flash as very much a mainstream technology these days. And there's a number of different deployment models where we can use to leverage Flash in different ways. We have basically the server-side model, which is basically a SSD or a PCIe card that obviously slots into a PCIe slot. And this is basically local storage. So you can use these however you like, and they can be used as a storage tier or a cache or both. We also are now seeing the rise of hybrid storage, which is a combination of SSDs or PCIe and hard disks. So we basically try to find ways to accelerate the hard disk tier. So that may involve doing something, for example, like caching a whole bunch of random I/O to a flash device and then writing that out sequentially to a hard disk. In order to maximize the overall I/O performance of the devices based on how they really like to be used. And basically, that's why you say we take these SSDs or PCIe cards and combine with traditional hard drives to get hybrid storage. And that's sort of a sweet spot in a lot of ways, that hybrid storage approach, because we get the best of both worlds. We get capacity and we get performance, and we're able to provide a good balance for both. And we also have all flash arrays, but those are still carrying a pretty high cost of entry, and they're often overkill for mainstream workloads. Now, there's lots of different arguments you can make across the board for these, but in general, all flash is still sort of an outlier use case for many, although it is growing in popularity as more workloads demand more performance.
Yeah, so we all know about Flash, from a consumer perspective. We're all familiar with Flash, in our iPhone or smartphone device. But I think, to me, the most common question in the data center is, yeah, sure, you can put Flash into, just about any piece of it. You could put it directly in the server and store, virtual machines on it. And no matter where you put it, things will run faster, than traditional disk. But the big question to me is, how do you know where to put the Flash and how to use it?
Yeah, and that's going to really come down to your applications and your individual needs. And there's, again, I think they're probably taking the approach of using all of these in a particular storage system, so you have all of the options at your disposal where it makes sense. Makes the most sense, not necessarily all flash, but SSD, PCIe, and hard disks. And we use, SSD as a tier, PCIe cards as a caching mechanism because they're ultra fast, and then we use hard disks as the capacity tier in most cases. So again, I think it just comes down to how do you want to deploy this, and what are the different ways. I mean, a lot of the ways we're seeing today, for example, PCIe cards being leveraged is being placed in front of traditional storage arrays. So rather than just write out to, for example, an all-disk SAN, it'll be written to the PCIe card first, and as I said before, and then basically over time written out to the disks in a way that makes sense to maximize the performance of those disks. So in that case, it's being used as a caching mechanism, and for things that are ultra-high performance needs, you basically use it as a storage tier. But obviously, just having a PCIe card or an SSD in a single server as a storage tier can leave a lot to be desired, because we have some potential issues of data availability. How do we actually, what do we actually do if that notebook happens to fail? So from a scaling perspective, on its own, just sticking PCIe cards in servers doesn't make a lot of sense. There needs to be something that brings it all together in order to work as a cohesive whole that can then provide data resiliency and overcome failures, potential failures in the data center. We'll be talking about that as a part of our software-defined storage journey here today. So what has Flash done for us, though? It's really helped solve serious performance challenges. Now, again, this has become the new throw hardware at the problem. We're now putting Flash in place, and rather than just buying a whole bunch of spinning disks, as David mentioned, we're looking for the right place to put Flash in order to be able to solve some of these issues. And this has brought some sanity back to the cost per IOPS metric. I've done these calculations before on traditional SAN environments with all disk, and the dollar per IOPS on a traditional disk can be just stupid, especially as you have to add entire disk shelves just to get more IOPS out of an existing storage array. And this has allowed customers to better balance storage capacity and performance, and I think that's real. As you look at the dollars per gigabyte, the dollars per IOPS for a hybrid storage array, it's really impressive to see just how low the dollar per IOPS gets when you start having the ability to cache things in Flash before writing it out to disk. But Flash storage has not solved storage complexity alone. In fact, it may have even exacerbated it a bit. And so we have to try to find ways to shield that complexity as much as possible from both administrators and users. When you really think about it, the administrator, we don't want to have messing around with storage all the time. You know, as David mentioned before, I spent 10 years in the CIO chair, and I don't want to have to hire more storage administrators. I want to hire more business analysts and things like that. So I want to make things simple. I want my people to be able to push buttons and make things happen instead of having to spend weeks upon weeks configuring and messing around with dials. So we have to make things simpler for the IT department as a whole in order to be able to help them focus more on what the business wants them to focus on. So a lot of this complexity and the cost and all of the challenges we've seen have really renewed focus on storage. And storage has become an incredibly exciting place these days. And I never thought that would happen. You know, as I'm looking at, 15K RPM disks coming out, I'm like, yay, let's throw a party. But really, with the rise of Flash, I think we've seen a lot of excitement and a lot of new use cases around storage. And there's been a lot of companies that are trying to leverage this in the best possible ways for their customers. And as a result, we're starting to see an increasing frustration with proprietary storage. We want things that are more open. We want things that are easier to use. We want things that make sense. And there's also increasing concern around ability to scale. I mean, this was a frustration that I had in my CIO jobs as well, is, okay, I have to buy more capacity, and it's just so expensive. I've got to have a better way to do this. I don't need to have another 15 terabytes of storage, but that's what I need to add in order to be able to get to the next step of this storage environment. Then we have the shift from physical servers to the hypervisor. Now, when you think about it, our workloads, our applications no longer run on servers. They absolutely run on hypervisors. The hypervisor is the layer upon which applications run in all of our data centers now. So we have a storage that has some challenges running in that kind of way and in that kind of an environment because of the I/O blender effect that I talked about before. And again, that increases our concern around our ability to improve storage performance and meet the emerging performance requirements that we see from a lot of our newer applications out there. Now, again, the common one everybody mentions is VDI, boot storms, things like that, and it's real. Those are things that we need to be able to overcome, but it's not just VDI. We have big data analytics, and if you think big data analytics is only for the large enterprise, if it hasn't hit your organization yet, it will at some point. It's going to hit all of us. We're all going to be wanting to do lots of analysis on data, and we need I/O in order to be able to do that.
And Scott, I want to point out, I think just about every enterprise out there has become more and more interested in storage, simply to be able to get more VMs per server. So to increase their VM consolidation ratio, in many cases, they have the compute and they have the RAM, but they just don't have the storage, the IOP capacity. And so they're looking for solutions, to solve that problem and help them get greater efficiency out of their virtual infrastructure.
Absolutely. And fortunately, there's ways to do that, as you may have guessed. And I've talked about this, so I'm not going to go over it. David, you want to say anything about anything that's on this slide?
I'll just add that, for those of you out there who are kind of confused about the I/O blender effect, when I first read about it, I was like, what are you talking about? If you think about just your traditional desktop or laptop computer, say connected to the internet, you've got a whole bunch of different applications going on at one time, email, web browsing, who knows, you're connected back to the VPN. You've got all these different things. They're all going through one wire, and for the network, that's the norm. That's just how it works. But with storage, as Scott talked about, we started off, with this direct attached storage model or concept design where, the application, email in one case or the database in another case, it has dedicated storage and it's talking directly to that storage on a dedicated wire. So essentially there's nothing to compete with. So with virtualization, you consolidated all those different applications into one place. And then now these servers are doing so many different things, but yet in most cases they still just have one or two paths to the storage. So all that different I/O and those different I/O types and use cases, they're all being blended up together. So your printing traffic is blended up with your most critical tier 1 application, all going to the same storage down the same path. And that makes the storage path, inefficient. And then as Scott talked about, it also makes the storage operations, inefficient because the disk just simply wasn't designed for that type of constant random reading and writing. So we need to find ways to solve that I/O blender problem, and software-defined storage. I mean, you're not going to solve it just by adding faster, flash to your storage infrastructure. That might sort of mask it for a while, but you really need smart software, to solve this I/O blender problem, to provide some sort of, storage quality of service, and so forth. Scott, what's your take?
Completely agree. Couldn't agree with you more, in fact. I think that we have to be able to find ways to improve the storage paradigm in order to meet the needs of the business. And that's what we're going to talk about in the next few slides here, is the way that software-defined storage can be brought to bear. And what is software-defined storage? So we have all these trends that have come together. We have opportunities to rethink data center economics. And again, I think that's really around flash. We think about storage in a different way from an economic perspective. That helps us to start rethink the data center in a different way. Let's not just think about storage. Let's rethink the data center with storage as a focal point of the data center, because when you really think about it, it really kind of is, because all that data is really the lifeblood of the business. And we start thinking about software-defined everything, factory-defined nothing. All brains of configuration reside inside flexible software. There's no ASICs, there's no FPGAs, there's nothing proprietary that stores any of our configuration information. We have flash storage, solid-state storage, helping to eliminate performance questions from the storage equation. We also see the commoditization trend. So we're starting to use less expensive hardware, even as we jettison some of the proprietary hardware from our data centers. And we'll talk about all of that as we move forward. Software-defined storage is really a new way of thinking about storage. And you can see on your screen that we've got software-defined is already in our data centers. We already have software-defined servers, right? VMware and Hyper-V, what are they? They are software-defined servers. Do you have physical servers? Yes, but all of their hardware is abstracted, and you've created virtual servers that look like physical servers on that abstraction layer. And so you've created software-defined servers already in your data center. We also are seeing software-defined networking at the networking layer. And in the storage layer, we have software-defined storage players, including NUTANIX. And what we're seeing an emergence, a more emphasis on then a services layer around management, automation, and orchestration to make our data centers much easier to manage. And our goal here, in some ways, is to throw away some of the specialized hardware that we've used in the past and build in the software some of those items that will replace hardware functions. For example, instead of having a RAID card that adds the need for a whole bunch of parity calculations, perhaps in software we write a replication engine that stores copies of data. Bear in mind the capacity in the storage equation these days is relatively inexpensive. You can go buy 4 terabyte hard disks for not that much money these days. So starting to think about how we are going to emphasize performance that may be at the cost of capacity starts to make more sense these days than it might have in the past. And when we start thinking about getting rid of some of this specialized hardware in favor of less expensive hardware and wrapping it in a software bundle, we have to make an assumption that hardware can and will fail. So we don't wonder if it will fail. We know that it will. And what do we write? How do we develop these software constructs to handle various value domains? What do we do if we lose a disk? What do we do if we lose a node in a storage cluster? Let's think about all those things in a software-defined way. So we buy inexpensive hardware and we use software to work around all of these various challenges. Now, one of the other challenges we mentioned before was the addition, the complexity of the storage area network. Now, we've talked a lot about simplicity in IT, and fiber channel is not necessarily rocket science these days, but it's still something else to manage, something else to learn, something else to have to get trained on, something else to support, and something else to continue to maintain. So let's think about just getting rid of that whole paradigm. Let's just work with Ethernet. Let's go to 10 gig Ethernet as our standard to a server in our data center and move back to a DAS-like architecture. Now, one of the challenges we had in that era was, again, we had these islands of stranded storage that we needed to be able to free in order to be able to leverage all of that capacity for the good of the organization. So to that end, we'll bind together these resource islands with a distributed file system. So as you can see on your screen, we take this storage layer. These are a combination of solid-state disks, PCIe disks, and regular hard disks, and we'll create a file system, a global file system that spans all of these compute nodes. In order to have them all talk to one another, we'll create a storage controller on each node in the compute storage cluster that then handles this global I/O translation. So how do we make sure that all of the VMs on node 1 can talk to all the VMs on node 3, for example? So basically, we combine, and when we combine software storage into compute, we're combining all the storage, putting it into the compute layer, and saying we're not taking a more of an appliance-based approach to our data center. And that carries with it some interesting benefits we'll talk about in a couple of minutes. I want to talk about the NUTANIX host architecture and how it aligns with some of those things that I just talked about. And there's a lot of benefits here that we'll talk about vSAN shortly as well. From the NUTANIX perspective, if you look at what we have running right now, you're looking at basically a single appliance here, a single node on your screen. So we have a CVM. This is a controller virtual machine that runs on each node in the cluster. This is where we provide a lot of our services. So we're exposing to the rest of the environment iSCSI, NFS, SMB. And by writing software, if Nutanix wants to and there's customer demand, they can simply add a new interface or a new feature. This controller virtual machine is also responsible for compression, deduplication, replication, disaster recovery, and basically any other storage-related services that we would have done in custom ASICs or custom hardware in the past. And as you can see, this controller VM approach allows us to be hypervisor independent. In fact, Nutanix today can work with vSphere, Hyper-V, and KVM. And if they wanted to and there was customer demand, they could add for a new hypervisor that comes down the line tomorrow. They're hypervisor independent because of the fact that it's a controller VM architecture that can move from different hypervisors to other hypervisors. Now, when we start thinking about moving from a software-defined storage perspective, storage into the compute layer, there's some things we have to think about. One of them is data locality. When you think about the way that we're looking at storage defined today, it's really a scale-out type architecture where we have lots of nodes of storage that we are bringing together into one cohesive whole. So think about, you may have 16 servers in your data center. Tomorrow you may have 16 Nutanix nodes or 16 vSAN nodes that are all going to be your storage and your compute layer. So that entire stack of servers becomes your SAN. It really replaces your SAN, and it also is your compute layer. So we have to think about things like data locality. How do we maximize our performance and make sure that we are keeping high level performance and also increasing the overall reliability of our environment? This is a mechanism to keep data local wherever possible. And so this minimizes network traversal, decreases latency, and it really increases performance, because if you don't have to go up to the network, you don't have to worry as much about what it's going to mean from a latency perspective. We also, in software-defined storage, start thinking about things like tiering, deduplication, server-side flash. All of these things are done automatically in a software-defined storage environment. It depends on the vendor, obviously. But in a lot of the software-defined systems, these types of services are provided in software. Not server-side flash, obviously, but flash is leveraged in order to improve the way that some of these services work. Now, one of the things I want to mention is, if you look at the diagram on your screen, the VMIO, the VMIO operations, all go through that controller virtual machine that runs on each node. And that's how systems that rely on controller VMs, Nutanix is one, there are others, work. Basically, the controller VM is the brains of the system. All of these controller VMs work in concert with one another in order to be able to provide all of the storage functionality across all of the nodes in the cluster. And the beauty of this is, if you need more capacity, you simply add another node. And the nodes can be sized differently. So you can choose to add a compute-heavy node. You can choose to add a storage-heavy node. So if you're running low on storage, you can choose a storage-heavy node to add to your environment, put it in the cluster, and Nutanix just subsumes it and assumes responsibility for it. It's pretty much that easy. And it's also pretty much that easy with other types of systems that work like this as well. And again, in these types of systems, the controller VM determines exactly how the flash layer is going to be used. Will the flash layer be used as a storage tier? Will the flash layer be used as a caching tier for performance reasons only? So when we think about it again now, storage itself becomes a building block resource, just like servers. So when we want to, as I said, add more storage, we simply add another server to the pool. We have low latency thanks to data proximity in the compute layer. We don't have a storage area network to contend with anymore. And this makes us have less complexity in data center architecture. And this also provides us with some areas of cost savings that we may not have seen before. We have quicker time to value in initial infrastructure purchase. So when you think about buying a new data center, there's a lot of time that goes into deploying these things. Well, when you start taking an appliance-based approach, it's a little easier. You basically put it in the rack and cable it, and in the case of Nutanix, it uses a Bonjour-like protocol to discover a new node, and it just adds into the pool. And other systems are similarly easy to use. There's no need to significantly over-provision resources at the initial buy. You buy what you need for now, and then as you need more, you just buy another appliance. And this is the same way it is with vSAN as well. You don't have to worry about buying all of that storage capacity up front or all of that compute capacity up front. You buy what you need and then grow as you need. So you don't have to spend a lot of money and have it just sunk there and sitting in your data center. There's less cabling, less hardware, less manpower, less cooling, less rack space. There's lots of less benefits that we can think about when it comes to when we start taking a software-defined storage integrated into compute approach to storage. There's also less need for complex proofs of concept. If you need to build a proof of concept of an entire data center, that can take a long time. If you need to take a proof of concept of a software-defined storage system, you can either order an appliance to try from a company like NUTANIX, or in a software-only play, you can download a trial of their software and play with it, for example, vSAN. And then there's lower ongoing costs as new resources are added for the reasons that I've already mentioned.
And Scott,
go ahead.
Yeah, this is where I think we're able to connect back to the original IT challenge I was talking about, where IT is being forced to do more with less, and we need to step up and become the infrastructure admin, really the data center admin, and no longer have those IT silos. But we can't do it with the traditional complex systems we have, and so this is the approach that I really like to make that all possible. Integrating storage into the compute and just really simplifying everything for the life of the admin, and then and in effect that's going to lower overall cost in the data center and allow us to do more with less.
Absolutely, and that's really what this is. I mean, when I look at things, and again, this is what we would call hyperconvergence or server SAN as well. These integrated appliance type approaches. Including even a vSAN type approach. But these are the kinds of solutions that I think are going to have to be thought about by CIOs in many organizations in order to really simplify the morass that's become the modern data center in a lot of cases. There's simply got to be less manpower spent on hardcore technical and more spent on business-focused needs. And I've shown this before, but in a different way. I want to just show you the NUTANIX way of scalability, where we have these controller VMs running on each node with the I/O going to the hypervisor, and then their distributed file system basically managing the whole thing. In most software-defined storage solutions, you're going to see some kind of global file system that is handling the scale side of this, because these are all scale-out type systems. So we add hardware and we add additional storage capacity when we scale in this way. So there's got to be some kind of overarching file system. In this case, it's NDFS, or the NUTANIX distributed file system, that manages it all, or we end up with stranded storage resources, just like in the bad old days. So these really, when you think about the data center resource silos, again, when we start thinking about storage, compute, and networking as separate silos in the data center, there's lots of inefficiency. There's communication issues. We also have a need to be able to keep those teams staffed. I mean, if you keep these individually staffed, there's a minimum of 3 people, but probably more like 6 at least, if you want redundancy, in order to be able to meet the needs of all of these areas. We're seeing an emergence of basically the data center expert, somebody who knows multiple areas and can work across multiple areas. In a lot of cases, this is the virtualization admin who's had to work traditionally with storage, networking, and servers over the years. I still think we have to break down these silos in order to get a lot of the performance gains, efficiency gains that we're talking about when we start thinking about the data center of the future. Now let's talk about some different ways we can approach the software-defined storage equation. We're going to start with one that's been on a lot of people's minds lately, and that's vSAN. This is the kernel integrated approach that VMware developed. And basically the way that it works is the storage, all the storage brains are built into the vSphere kernel. There's potential here for better performance than we see from a controller VM type scenario. But there's a big caveat there. I would have a hard time, I think, saying that they're going to be significantly more performance, because over the years, we've really seen the I/O capabilities of hypervisors, both vSphere and Hyper-V, grow significantly. So we can run these massive I/O intensive virtual machines now with really no issues. When you think about it, the controller VM is an I/O intensive virtual machine. There's a lot of, I would say, collateral out there saying that the kernel integrated approach is better. I'm not sure it's better. I think it's just different. It may be slightly better performance, but I think it would be hard sell to say, oh, hey, these things are not better performance. I'm sorry, the controller VM approach is bad because it has these I/O limitations, while at the same time saying, but run your biggest workloads on the hypervisor because it can handle the I/O. I don't think you can have it both ways. And if you look at any of the performance metrics that have been performed on both approaches, kernel integrated may be a little bit better, but the controller VM approach is hardly a slouch, and it's able to keep up. And think about the fact that you can scale it as well if you do need more performance. Now, vSAN is potentially as simple to use as a NUTANIX thanks to the integration pieces. So especially if you look at a vSAN ready node, you can get something that's ready to go tomorrow. Now, the procurement model may not be quite as easy as you get from a NUTANIX, where you basically call them up and buy from one place, but it's still certainly not bad. But there is going to be much less product flexibility. You are not going to port vSAN to Hyper-V because of the fact that it's built into the kernel. Somebody would have to build that same service for Microsoft, maybe it's storage spaces, in order to have a similar service on that side of the house. Now, one of the other challenges we have here with that approach is these are software only, and you may not know the exact performance or scale capabilities of the underlying hardware. So one of the concerns that I have about vSAN, and again, I like vSAN, but if you're not familiar with vSAN, by the way, it's VMware's virtual SAN. I should have mentioned that before. This is basically an add-on you can get for your vSphere environment that allows you to basically create a distributed file system out of your vSphere hosts up to 32 nodes in your cluster. So you have to buy hardware that's on an HCL, hardware compatibility list. And the vSAN layer, while it may work with all the hardware that's on the HCL, you don't get insight into the exact hardware specifications, which makes it a bit more difficult to support and a bit more difficult to get a good expectation of what the performance capabilities are really going to be of the environment. When you start looking at a hardware-software bundle, now a vSAN ready node may be a different case here, but this is also another case where NUTANIX shines. So a vSAN ready node is basically a pre-built vSAN appliance that you can get from a VMware partner. These are going to be provide better understanding of the hardware, which even in a software-defined environment, hardware remains critical. It's going to provide easier support and simplified performance tracking capabilities. So the other architectural approach to software-defined storage is in user space or running as a virtual machine. This enables an agnostic hypervisor environment. In fact, according to ESG, 55% of enterprises have or will have a multi-hypervisor strategy. At Wikibon, we're seeing the same results. More and more organizations are adopting multiple hypervisors to meet different needs in the organization. It's easier to build in resiliency because you only have to worry about the storage fabric. If you're in the kernel, you have a lot of other things you've got to worry about. If you're building a controller VM, you just have to worry about what's happening on a storage basis. Now, as I mentioned before, people complain that the storage I/O path in this approach is more complex because you have to go through that controller VM for everything. But again, it's hard to justify that while also saying that other VM I/O can be really fast and high performance. So I don't really buy that argument personally. It's something I think that people would need to test, and if you really need the top-notch level performance, do a test between vSAN and another SDS approach. That is the end of our webinar today, but we'd like to take questions, and we actually do have a few questions that have already come in.
Yeah, let's go ahead and start with one here. The first one is that they're asking basically, is the software-defined model that we've been describing here, is it only good for large enterprises, or might it even apply to the SMB or the SME space? For example, let's say that what they are asking is, let's say you just have a VMware Essentials license. Could you still take advantage of this SDS model? Dwayne, do you want to handle that?
Yeah, I can take that. Thanks, David. Yeah, so I think SDS is for everybody. Obviously, from a NUTANIX perspective, we have a lot of enterprise features, but we also have a lot of customers with a vSphere Essentials standard, not being tied to any type of management construct that allows all of our customers to enjoy the benefits. There's always, cost is always a factor, but I think the real story behind SDS is the ability to respond to business demands quickly, and also, buying what you need when you need it, instead of kind of the Costco approach of, buying the case lot of gear and then hoping that you need to use it one day. So I do think it is for everybody.
Okay, good info. Second question here is, how does this technology align with or perhaps enable disaster recovery and business continuity?
From a NUTANIX perspective, anyway, I think we would agree that it does need to be tightly coupled. There's a variety of SDS solutions on the market today, and some of them take DR as a secondary point and have it sitting outside of the solution as a secondary virtual machine or an appliance. But since if you're looking at the whole I/O stack and you're looking at performance in general, there's so many, all of the different services you provide, like snapshots and compression and DR, they all have an impact on the underlying system, so it does need to be integrated. And then really, you should be able to place the whole concept of software-defined storage is providing that next layer up for the software-defined data center, meaning you should be able to place any workload in any part of your data center, whether that's remote or local.
And what about replication? I mean, with a traditional SAN, you had to buy an expensive replication license, one for each side. How does NUTANIX handle that?
So, it's really taking the cluster mentality, taking all of the nodes in the system. They're all helping to participate in replication, so there's not one bottleneck. And then, taking that notion of factory-defined nothing and really being per VM, you have the ability to pick and choose your applications that you want to send over the wire with compression and dedupe, and then you don't have to kind of go through a long business continuity planning, because it's simple as drag and drop instead of trying to architect around LUNs and other hardware designs.
So you're saying that replication is built in?
That's right.
Very cool, very cool.
David, I think that's all we have time for.
Okay, well, thanks so much, everyone, for attending. We got a lot of great questions here. If we didn't answer your question, we will be following up via email. So, look for that. We'll make sure that we get every question answered. Thanks so much, Scott and Dwayne. Any final words, Scott?
No, thank you all for attending today. It's much appreciated. We look forward to seeing you in the next two parts of this series.
Thank you,
everyone.